right, what is up, everyone? Week 130, building my own operating system. Welcome. Thank you very much for joining. Today, we will move forward with the integration test stuff from last week. As usual, quick intro message from the sponsor, which is me. I would love to talk to you about your challenges in the world of systems programming so I can find out how I can be more helpful to my audience. So just feel free to get in touch with me. If you have technical challenges, career challenges, something else, I'd love to hear about it. Here's my contact info, Discord, Instagram, email, anything works. Would love to hear from you. All right, and so without further ado, week 130. And today's 26th. I'm feeling pretty good. Feeling some pretty good energy coming into today's stream. As usual, we'll get the test 0 in the chat. Yeah, so last time I started a new topic, which is an integration test framework for the kernel. So I'm optimizing, or rather I'm investing pretty heavily into test infrastructure for my kernel. And I'm doing that because I'm just curious about it. I think a lot of other hobby kernels don't really invest very heavily into test infrastructure. And so I'm just sort of curious what it looks like. I've had unit tests for a very long time, but now the idea is to get into integration tests, which operate at a higher level. It's sort of more just holistic booting the kernel and being able to observe high level functionality about how things are working. So we made a lot of good progress on the integration tests, that test framework last time. We're going to continue that today, and I think we'll get it into a pretty good state and hopefully write some of our first integration tests for some of these cases that I identified last time. What's up, Sensei? Nice to see you. And what's up, Pranav? Thanks for joining the chat, guys. Yes, sir. Okay. I'm trying to think anything else really needed, or maybe we can just get into things. Yeah, let's just start jumping right in. It sounds like completely on time, super punctual. That's awesome. Okay, so let's briefly refresh on what happened last week. Yeah, Lane, what is up, Lane? Gonna start getting into OS Dev today. I'm also subsequently working on compiler development. So I've got a lot going on. Wow, that's ambitious. Best of luck to your double ambitious projects. Asans, what's up? Digitalized in the chat. What's up, Digitalized? Got a stacked chat today. That's awesome. Thanks for joining. Careful, Lane. Watch out, though. I think this is a common. You're treading into dangerous territory by trying to simultaneously develop an OS and a compiler at the same time. I think many have proceeded on that path, and bad things have happened to them. So watch out. Stay safe on your journey. All right, let's take a quick review of what happened last time. So, right. The whole topic is integration tests. Integration tests. What is an integration test? The idea behind an integration test is, unlike a unit test where it, like with a unit test, we take a very specific function in the kernel or a very specific class or sort of like module. We instantiate it in user space and we just run some, we just call the APIs, we just call the function, and we just verify that the outputs match what should happen or the appropriate state changes are made if it's a class that's modifying a state. Unlike unit tests, integration tests are more about very high level behaviors of the system that are either very difficult or just completely impossible to run in a unit test environment. And the general intuition behind an integration test is just like, let's take the system as a whole, fully rigged up, and boot it. Like in this case, it's a kernel. Let's just boot the kernel in QEMU, and we'll run some code in the kernel, some custom kernel tasks, and we will sort of either verify things based off of the serial output, or we'll just have some code running in the kernel that verifies that the test worked. And examples of integration tests are things, these are all like real things that I've done before to manually test the kernel. For example, for a long time, I was trying to test that my guard pages worked, and I had this function that would just try to write to a guard page, and which should page fault. And I was just manually looking and seeing that a page fault message printed on the serial console. But it's annoying to just do that manually every time I do a change. And so the idea is to write some kind of test framework where that can just be one of the tests that runs in the test suite. What's up, LM Kira? Do you have ETO code kernel? Sorry, I don't quite understand the question. Maybe you can rephrase it. Yeah, a real bug that I had was that I didn't preserve the flags during the context switches. So that theoretically is another integration test we could write, because like that, this would be very, very difficult to unit test, if not impossible, because it involves multiple tasks switching between each other and then verifying that the flag's state is saved during that transition. And so it's not like a nice simple function or class where you just instantiate it and like test it. It involves sort of like the whole system existing with two tasks and the scheduler and this context switching and stuff. So, yeah. Let's see, digitalize. Will I be doing fuzzing as part of the unit tests? Maybe. That's not in this current scope of the work I'm doing. I would even consider that another totally separate kind of test. That they all just sort of complement each other. So like unit tests, integration tests, fuzz testing, it's all different parts of overall comprehensive test suite. So that's not currently the focus, but we could look into it in the future. Yeah, it would sort of be interesting to think about what would fuzzing really mean for a kernel. I think what I could think of is like there's this thing called syscaller, which is used to test the syscall surface of Linux, and it finds a lot of kernel bugs. And so I think fuzzing in the context of a kernel is probably something along those lines, or maybe on a device level, although that's a bit more fuzzing drivers. Can't use single-step QEMU and dump registers. Yeah, so that's definitely possible, and it feels that's more of like the manual testing approach, where it's like, yeah, we can run the kernel, single step it, and just sort of like dump the registers and verify things. And the idea is to not have to do that manually, but have some kind of automated test suite that will run like a flags are preserved test and just do that in an automated way. So last week we started on this, and the approach was like the hard part about doing this. There were a couple decisions to make, and so I think the first decision we made was that we could either just put everything we could build the tests just into like the production kernel itself and just have like the kernel, this one kernel just be like everything, where the kernel binary, it's like both the production kernel, but also builds a bunch of tests into it that get activated if you pass some flags. Or there's another approach where I could actually have two different things. I could have, I'm not quite sure where we talked about this. Maybe it's over here. We could actually even have a separate test kernel that has the tests baked into it, and the production kernel has no tests, and it's just the kernel. And what I decided to do is to just put everything into the kernel, one kernel image. And the reason I chose to do that is mostly just out of build system simplicity. I'm trying to keep things a bit simpler for now, and let me just clean up some of these tabs. Yeah, I'm just trying to keep things as simple as possible. If we, in the future, if we decide that the kernel is getting too bloated because these tests are getting linked into it, we can always extract it out. But for the time being, I'm just putting everything into the main kernel. And the general idea is that we basically are introducing our very first kernel command line argument. And it is the test argument. And it, and then so there, with this argument, you can pass this command line to the kernel, and that basically tells the kernel to flip into like test mode. And so it's not going to run the normal boot sequence. It's going to boot into specifically this test mode that's going to run a single unit or integration test that is specified by a test ID. So I'll show you a bit more about that in just a second. Afnan, what is up? Nice to see you, Afnan. CMake scares me. Sold my soul to Basil. Oh man, that's getting into the dark arts of corporate C++ development or whatever. I tried Basil once, and it seemed very heavyweight to me, and so I didn't continue using it. What's up, Johnny Rage? Do I use AI for anything? Yes, definitely. Not for vibe coding really, but for asking questions and doing some design work. Is it possible for a beginner to build an operating system? Mr. Fun says, of course not. I would say an OS is not really a very beginner-friendly task, to be honest. It's sort of the pinnacle of a lot of different topics of computer science all coming together at once. So yeah. What's up, Corelli? Passed my saying, started studying C and C++ because of you. Oh man, well, good luck on your journey. Appreciate it. Popsicle, take a long time. Best of luck, thank you. Does the stream have some artifacts? And where's it? Oh, where's the stream chat window? Good call. It did not appear today. Ray, what is up? Resource. Okay, this is a problem. Where's the chat? Oh, let me see. Do I have it? Break a leg. Chat is popping off today. That's really cool. Okay, quick little pause while I try to figure out why the chat widget decides to break today. Thank you, Afnan, for letting me know. Okay, that is very unfortunate. I'm using OBS. Let me see. Give me 1 second. So as far as I can see, I'm using Streamlabs. This thing seems to be enabled. Save settings. I won't spend too much more time on this, but it is always a little bit annoying when the chat box doesn't work. I'm trying to think if there's anything else I can do. So this is the little test thing. It's working over here. Maybe the... Okay, I will give one last ditch effort to try to fix this chat box. Yeah, it works over here. It's like this is like this URL I get from Streamlabs, and gotta love the live debugging. On stream. Too bad. Too bad. Yep. I don't know. I guess I will give up on this for now. It's not important. Yep. Weird that this thing works. Yeah. All right. You know, some days you get the chat box, some days you don't get the chat box. All right. I don't want to leave you guys waiting around watching me fiddle around, so we'll just go without the chat box today, unfortunately. New haircut? What's up, Wall Marcus? Yes, I got the haircut. Got the haircut. Where are we at, mate? We're going to continue with the integration test work from last week. Resources. Did someone post the resources command? Yeah. So this is not the most amazingly curated resource list, but it is... Oh, wait, dang. Wait, maybe chat commands don't even work today because... Wow, crazy. Okay, so the bot is there, but the chat widget is somehow just it's not working. At browsers. I think that's live on the... I think everyone can see that right now. That's crazy. So okay. Yeah. Okay, that's it. I'm gonna stop. Anything else? What's up? Babu Delhi? Okay. Purely C and C++. Yes. Yes. Okay. Like I was saying, okay, let's get back into it. So basically last time we started on the test framework and here's how it looks. And so what I can do is I now have this script called run test. And it basically boots the kernel with a specific command line argument. And it is sort of annoying for how it has to do that. It actually needs to generate, like dynamically generate a image. Yeah, like an ISO image just for the unit test. It flashes on the left. Okay. Yeah. Let me just lock in a little bit. So basically, anyway, without explaining absolutely everything, basically the idea is we want to just have a command line argument over here in the kernel, and we can then check that argument to see if a test was given, we're going to boot the kernel into an alternate path. And yeah, this is the thing, Sensei. Are you baking a single image for the test or an image per test? The way I need to do this is the second way, an image per test. And the reason is because of how passing kernel command line arguments work. And so on the kernel side, I can access some command line arguments, but the way you pass them is you need to put them into the bootloader config. And we're already at the first 20-second break. So feel free to join me. I'll be right back for a quick stretch. But yeah, like here's how it works. Like if you want to pass a command line argument to the kernel, it's sort of, it's different from just like user space where you just run the program and then you just pass stuff. For the kernel, you need to put it into this bootloader config, which then gets baked into the ISO. And let me see. Okay, that booted the kernel. I didn't want to do that. Let's get a timeout going. Yeah, so basically this is how it looks. So basically, you put it into the bootloader config, and then you can sort of just select one of these sort of like canned presets. And that's what you need to do. So it's really annoying if you just want to pass a command line argument to the kernel. And so in order to work around this, I've built a script that generates an image and fills in this thing kind of like on the fly dynamically. And so what that looks like is this run test script. And so when we run test, we're going to pass in a test ID, and then it's going to dynamically create a bootloader config and package that up into an ISO on the fly, and then pass that thing to QEMU. And so that's how I've chosen to design it. And so the way it works is basically like, this is what I got as far as last week. It's like, we can, here's like just some dummy code. It's like, okay, if we have a test ID, if it says pass, we'll print out passed. If it says fail, we'll print out failed. And it's just that. And so now what I can do is I have this wrapper script that basically allows me to run the kernel as if with a similar sort of like UX as if it was a normal user space program, where I can just sort of like run this program and then pass args and then just sort of run the kernel. And so that was the first kind of baby step that we did last week. And if I pass something unknown, it triggers this test failed thing. And so that was already, it took quite a bit of work to sort of figure out how I want to do this. But that was last week. So, oh, hello code, what is up? What is up? Yeah, chat's popping off today. We've got a bunch of people in the chat. That's really cool. $45 people in the chat. That's a lot more than usual. All right, so let's make a plan for today then. So basically, yeah, here's the plan for today. So now we have this basic infrastructure, and we need to move forward somehow. So we need some way to, this is really more like the framework part of it. We need some way to register integration tests. We also need to decide on how exactly a test will pass or fail. Like, what is the exact mechanism of how that works? I think my first idea, which I think is not really the best idea, is that it's like watch for specific output on the serial console to pass, fail a test. So for example, yeah, just tests are just, the test is going to configure the kernel with a couple tasks. They're going to run, they're going to produce some output, and the test framework can watch to see if it gets the output it expects. And let me, yeah. It's a good stream, man. Thank you, Ray. Appreciate it. Honestly, I was a little bit nervous about doing this topic because I kind of felt like it was a bit more of a boring topic relative to more spicy things we might get into. But honestly, I think it's actually a very interesting topic, and it gets into an area that a lot of people don't do in their hobby kernels. And this is the kind of thing you would have to think about if you were ever seriously doing a kernel. And so I find it interesting. Test suite runner is spicy. How do you get the output? Serial? Yes. Yes. Just QEMU. Like all the logging just goes out of the serial console right now, which is super easy because it goes out from standard out in QEMU. And so it's very easy to get the standard output. And so let's talk some pros and cons as usual. The big con of this is it's fragile. Test depends on specific text seen on the serial console. This will break if the logs are ever changed. That's a major downside. Another downside is that the test framework is responsible for doing arbitrary kind of grepping and post-processing on logs. That's also kind of complicated. The pro of this size is fairly simple, not very invasive for the kernel. The kernel simply behaves as it always does. Yep. Tests are really, really important. For sure. What's up, Hermit? Your website is really helpful and resourceful. Thanks a lot. Oh, you're welcome. What's up, Scar0? Below. Okay. I don't know what that means. Yeah, you might be sad if you don't have a dedicated serial port. Dedicated. Yes. Yeah. All right. So here's the other option, which I am slightly less sure about here how this would work, but the idea is develop some kind of test protocol where the kernel sort of monitors itself via some monitor task and then emits a small set of defined text events on the serial console to indicate pass, fail, etc. And I still need to think about how exactly this might work, but it basically just has all the opposites. It's like not less fragile, but, yeah. It's just the exact opposite. It's more invasive. Invasive. I think it would be helpful to actually think of some example. I think a good example to test is this guard page test. Let's actually sketch it out, but in production, this writing to the guard page is going to like hard panic the kernel, probably. That's the desired behavior. But under a unit test, since we want to test this, I think there's going to be some code where the page fault handler is going to like branch. It's like, if we're in test mode, then don't hard panic the kernel. Instead, print out some message that says test passed or something like this. Yep. So like a watchdog. Yeah, I think you could think of it that way. I think watchdog can mean different kinds of things. Like if we're talking embedded systems, like a watchdog, you know, I'm not necessarily knowledgeable enough to speak deeply about that. But I mean, in general, a watchdog is like something that's sort of watching the system to make sure it's still responsive and it hasn't like hung in a big loop. And I think conceptually, yeah, we're going to have some kind of kernel monitor that will behave in a similar kind of way. And also, like a key point in how it's going to be similar is that this monitor or something here is going to be, it needs to watch out for timeouts in case the kernel ever gets into like a weird infinite loop and hangs forever. The test framework needs to watch out for this so that the test framework doesn't hang forever also. And so that's conceptually like a watchdog also. What's up, Chen Honjo? Can you show me the GUI? I don't have a GUI, unfortunately. I hate to disappoint you. Also, Bizarre Zip, great to see you. Also, man, chat is super stacked today. It's great to have everyone in the chat. Let's just try this out a little bit with like a really basic way of doing this. And so let me think. I think the first thing I'm going to do test is I don't want to like hard code all of this directly into the kmain.cpp, and so I'm just going to make a new file called integration tests. I don't really know what and I'm gonna snooze the timer, but I think that was a decent enough name. And as usual, I'll be a little bit lazy. I'll make it inline. And what we're just gonna do here is integration tests, and we'll pass in test ID. And I'll just so just to be a little bit more organized about it. Okay, this actually should be here, and then this args thing goes away. And then we need a bunch of headers. We need the logging header and the assert header. I don't know why this logging says it's unused when it very obviously is used. So just as like a tiny little cleanup, that's how we're gonna start looking. And so, yeah. This is inline just because I'm being kind of lazy. Like ideally it should be in this .cpp, but doesn't really matter for the moment. I'm just gonna put it in inline so I can just do it in the header. And I'll just make a small change which we can test. And so now if I do pass, it should fail. I think it paused because it was compiling the kernel, actually. That's interesting. Xpass should pass. Good. Okay. And fail should fail. So that's pretty cool. So now, we haven't done anything major. But, yep. So now we're in a position to start, start doing some more tests. And so now now it gets interesting though, because now we want to actually do our like actual first test. Okay, I'm just going to actually comment a lot of this stuff out for now, except maybe this. So now everything will fail, I think. It takes a long time. I think it's why would it be hanging? Because it's looking for it's looking for the colon. That's why. no, it's looking for even more. It is specifically looking. It's actually important that it prints test ID. Okay. That's why. Let's maybe simplify this a little bit. This is a little bit aggressive. I'm going to, it'll be sufficient for it just to say test passed or test failed. How about that? So now the test failed should work and this should fail. Good. So now everything fails. Right. And so now let's start doing our very first test. And so the idea is let's do this page fault test. And so we're just trying to recreate test write to guard page. Or maybe we'll call it faults or something like this. Yep. And we already have code for this here. So it was just this function called helper. And I would just sort of comment it in and out at various points. It seems to be commented in right now. Into the test0 task. You know, it'd be really cool. Cursed option, dynamic probe registration USDT style. We detrace then. I have to be honest, I actually have no idea what this means. Dynamic probe register. Oh, you mean like runtime probes or something like this? Oh, so maybe you mean something like the kernel boots and then at runtime during the kernel, it enables a couple probes that maybe behave in some certain way. It causes the kernel functionality to behave slightly different. Not super familiar with dtrace, to be honest. Okay, so here's what we're going to do. So we're just going to do the most basic test. Well, actually, even before we do that, let's just run the kernel and just see what happens with this helper test, just to get a basic kind of grounding somewhere. And so I'm going to go to kernel.cpp. I'm going to enable the test0 task. And now let's what happens if I boot the kernel? Yeah, good. So here's what happens. Right. It's running the test0 task. Dynamic instrumentation of static code. Interesting. So just to make that clear, I'll just add an extra print. Oh shit. Okay, just to really see that more clearly, we're gonna run it writing to guard page ... trap frame barf everywhere page fault. All right, second break of the day. Feel free to join me for a quick 20 seconds. So that's great. So right, ignore the fact that I have this weird function on the scheduler called write to guard page. But conceptually, that's what we want to do. So let's just get it really, let's just go really basic right now. So if test equals write to guard page snooze. Right, we're gonna call this thing, and let's actually see. I think we might need. I'm a little bit, yeah, still figuring this out, but what this what this needs to do is it actually needs to kind of queue up some tasks, and specifically it's going to kind of look like this. Task write to guard page, something like this. Okay. So something along these lines. Okay, this is super weird. This should not be necessary to do, so that's, we can call that to do. This should not be necessary in client code. The unmapper should take care of either clearing the TLB either by LCR3 or inval page. But whatever, we can fix that later. This is, we can remove this later, and I will just keep around this panic just, or maybe I'll make a test failed. If we should never get here, so like that's sort of the definition of test failed. So I'm going to call it test failed if we ever get here. And so now, so this function is going to call this thing. And this is not really lovely, but I'm just going to call kernel.run here. Because remember, like normally in the normal boot stream, we just call kernel.run. And so over here, we're basically doing a similar thing. The only difference is that we're using a kind of curated set of initial kernel tasks, as opposed to wait a sec. Okay, this is interesting. So the kernel already has this curated set of tasks that are hard-coded and run. So that's kind of problematic. Because in the unit test, I want to have full control over exactly what tests are passed here. And so that's kind of interesting. So clearly we don't really want to be hard coding stuff. Yeah, so what can we do? The first thing we need to do is sort of clean this up a little bit. Instead of hard coding things, we need to pass the data somehow. I think probably just the simplest way I can proceed here is, and this is a little bit sloppy, but I will just pass in, I'll have this function just take a container of tasks, and maybe a std initializer list is the appropriate container. Yeah. And so the AI knows exactly what I want to do. I want to, rather than hard coding, like test 0, blah, 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 I'm just going to take this container of tasks and then just put them in there. And so now the consequence of this is, so this changes, actually probably needs some, what is the include for the initializer list? Okay, this dev docs thing kind of sucks. What is the it's in, wow, it's in a header called initializer list. And I have that header in my headers, and so I can include initializer list here. I also need to technically do that here. And then now I need to patch every place that calls run, which is thankfully not too many. And so it would look something like this. Of course, now I need to include tasks.hpp. Oh, again, I'm being a little bit sloppy here, but this is just for the purposes of prototyping. So, right. So technically I'm using void pointers around. In theory, I should actually have some kind of like using like a type alias or something for this function pointer type, but for the moment I'm just I'm just kind of sort of slinging void pointers. Can't use M4 to swap that list at build time. Maybe. I'm not sure we need to swap it at build time though, per se. But maybe you're thinking a few steps ahead of me. So here's just what I'm thinking for the moment. So let me just go and kind of repair a couple things. And so I'm just going to panic build. So now the kernel should build. Duplicate symbol helper. Okay, that's unrelated. That just means we need to Oh, actually, no. Wait. Where is helper? Ah, okay, that's why. Not in line. We're in a header. This is the consequence of being kind of lazy and putting my function definitions in header files, which is not really good practice. Okay. So right, so now I should run the kernel and we should have the exact same behavior before. It's going to run the test 0 thing and write to the guard page. The difference now is now that I've stopped hard coding all the tasks in the run function, I can go to the integration tests and actually I can do this. Yeah, and the AI knows what I want to do. This. So now I can call kernel run with this this one task. I think what we'll just do is we'll just put this big test failed thing at the bottom just to catch. I mean, we already have one just to catch everything at the very end. And this is sort of what the integration test looks like for the moment. It's like if we pass this particular string in there, we'll just do this custom kernel boot where the only task that runs is this one little thing which writes to the guard page. And we should be able to see this through. So this is going to fail because I'm passing some bogus test. So now if I do write to guard page, it's actually probably still going to fail because it's just going to produce this is the log that's going to happen, which contains neither test passed nor test failed. And so it's going to trigger the timeout. And that's sort of the key question here of how I want to handle that. I see there's a bunch of chat stuff piling up. I'll get to those in a quick second, but just for a quick checkpoint, the way I will hack this for the moment is in the page fault handler. I will panic and say test passed. And so that's going to cause this to say test passed. And then that's going to be what the script is looking for. And if the script sees that in the output, it's going to pass the test. So I think with that, we can actually try this out. So we can do a bit of a moment of truth here. And so what I'll just do is I'll just run it, I guess. So when I run this, we're expecting to get to here, which will get to here, which will get to here. We're going to see all this stuff happen. Well, we're not going to see this in the output because it hides the output unless the test failed. But I think we're just going to see, we're just going to see it succeed. Pass, right to guard page. It would be, is there a verbose? Wow, somehow that argument got passed to CMake. What I would like to do is actually see the logs. I might reach for some vibe coding support with this. Yeah, let's do some vibe coding. Because I don't want to, but yeah, my models are all messed up here. Okay. Claude. In run test sh, please add the flag to the script that prints out the console output so I can use it even when a test passes. Wow. Okay, we're not going to use Fable. We're going to go with the poor version. And hopefully it can just vibe code all of this super easily. Okay, cool. So now we got the -v. So now if I do -v, here's what we see. And so it's exactly what we were hoping for. Kernel boots up. Kernel command line test equals write to guard page. Bunch of stuff prints out. Hit the panic with the test passed. So I would call that a win. Small win for today. Yeah, let's check the chat. What's up, Hex 4A4? What's your OS? I'm on Mac OS right now. What do you recommend for a person that wants to get into kernel dev? Any resources? Yeah, I recommend getting into these free university courses that are out there, like Harvard 61, MIT has one too. Kale ABY. What's Kale ABY? What's up, Program Paula? Thank you. Awesome knowledge. Font extra. What's the difference of H versus HPP in environment? It's sort of a matter of taste. I use HPP files for C++ header files because otherwise I find it kind of confusing. Because if you use .h for both C and C++, you can't tell based off of just the file extension what language is going to be in there. So, best way to learn C++. This is a kind of a tricky one. And I don't have an amazing answer. I think it's, other than following tutorials, you can watch some CPP Con talks. Ultimately, you need to be doing exercises though. And yeah, I'll have to look that up. Like off the top of my head, I don't have a great recommendation for that. There are some good books out there, but as far as exercises about C++, yeah, I'm not completely sure, to be honest. We can always write some basic projects, like write a shell, or maybe use some C++ libraries that you like. There's a lot of good C++ libraries out there. 130 weeks is mad. Yep. Any suggestions or things you keep in mind if you started all over? Good question, Lane. I think, I mean, I've been really having great results with this whole strategy of following the university coursework. So I think I would avoid looking at the OS Dev Wiki for too long. I don't know. I think the OS Dev Wiki has just too much information. It's not clear whether it's all the highest quality learning resources. And so I would, I'll reference the OS Dev Wiki sometimes, but I wouldn't use the OS Dev Wiki as the only resource. Wow, I don't know what this thing keeps right-clicking on me. And my mouse is just going crazy. Tough. So what I did, lots of CPPCon videos, tour of C++, and built some project. Nice. Yeah, I mean, Digitalized has a lot of experience at this point as a C++ learner. Project Euler, Advent of Code also. That's also true. I think in my experience, Project Euler was very mathy, though. Also, I find Advent of Code geared towards kind of algorithmic programming, which may or may not be so exciting for the average programming learner. And so I think those are options. There's definitely lots of exercises there, but just be careful in case you get kind of bored or uninterested, because there's all sorts of other projects you can work on that are a bit less math or algorithms focused. vpool, what is up? If you're doing one test at a time, can't you push a task into the task queue after you're done? That would actually be the test framework, or a task before to set up the test framework. You push a task into the task queue after. I'm trying to see if I understand this. I just don't know if we need too much of this stuff. Really just what the test framework means is it's some way to register an integration test with the framework, some way for that test to get run, and some way for that test to be recognized as passed or failed in some kind of sense. There are, of course, all sorts of advanced things you could do in a test framework, which could or require some more support in the kernel, which might be what you're getting at. But for now, I think this simple version is sort of working. Sarkat's interested in embedded systems. Do you run learning assembly and C? Yeah, absolutely. I think assembly and C are just kind of just fundamental prerequisites for having a deep understanding of systems. So even if you're not going to be doing production development in C or assembly, knowing these will help you in any other language you learn, like C++, Rust, or whatever, just because these are the foundation of basically everything. So, kind of OS are you building? It is kind of like a real-time OS at this point. And this is the crazy question. When am I going to finish? I have no idea. That's sexy. Whoa. Sexy log and complexity. Legacy BIOS or UFI, Camiono. I'm using Legacy BIOS for now. But I'm using a bootloader that sort of abstracts this. So I'm not directly coding against Legacy BIOS or anything. So, yep. All right, so let's just do a quick quick little okay. So commit for adding the -v arg. Yep, no. Oh, this belonged actually in this commit. Okay. And this is all just some hackery. So let's keep it moving. So this sort of works, but there's some problems. Let's just make a bit of a roadmap. So basic guard page test is kind of done, but then we need to don't hack the page fault handler to print test passed. I think that's kind of the main thing. Yeah, let's just think about that for a moment. How long are you developing this? What's up, LPM codes? It's been maybe a year and a few months, maybe like 14 or 15 months now. Yeah, streamed all of it. Yo, did you breeze through the math courses in your college for a degree? Not really. I wouldn't say so. I wouldn't really say math is just like my strong suit, to be honest. I took some math courses, but I studied computer engineering, which had some math, but it, you know, it's not the most math heavy thing to study. Okay, so we need to get rid of the weird write to guard page API. But the most interesting thing is going to be kind of getting into this this kernel monitor itself kind of thing. Yep. Are you using that Ableton thing as a stream deck, by the way? I'm not. I formerly had it rigged up to trigger some sound effects. I probably could use it as a stream deck, but I'm not doing that currently. Why not C? Classic question. Really, just the answer is I know C++ much better than I know C, and so and there's a lot of nice things in C++, so just using that. How do you test if your code is running right? Can you see any page or result? Exactly. That's exactly what we're working on. Having integration tests to tell if the code is working right. My WordPress port 22 is port open. Okay. 20 seconds, be right back. Okay. So now let's talk a bit about how so this like sort of worked, but yeah, this is not really acceptable. We can't be out here hard coding tests passed. What actually this is exposing is there's kind of another problem where like currently any page fault ever just panics the kernel, which is not really the right thing to do. I mean, a page fault is not fundamentally a panicking operation. It's totally normal for a kernel to page fault. And so what I really need to do is we want to only panic, first of all, and this isn't even related to the unit test, we want to only panic if the page fault was in any of the guard pages. So let's, oh shit, guitar. So let's take a moment to refresh how the whole guard page thing works. So if we go to scheduler.hpp, we're gonna go to unmap guard pages. So in the constructor of the scheduler, when it constructs it, unmaps the guard pages from all of the task stacks. And the task stacks are stored in this separate area called the buffers area. And yeah, that's what we need to see. And pretty much we have the address in CR2 of the faulting address. So we just need to basically just sort of loop through these and check. So the question is, where does that logic go? It's going to be some kind of function. Task stacks is currently just this array. Who is responsible for this? I guess, I mean, I suppose that it just could be a random free function in this file. Is adder in guard in any guard page or something like this. And we could get passed in a maybe a scheduler buffers, a const scheduler buffers, and a void star, something like that, possibly. And it's just sort of like turn false for auto, for auto stack in buffers.m task stacks. If greater than equal to stack.guard page dot, yeah, what is like dot data? I'll have to double check myself on this, but that's just sort of the idea. It's like, okay, we have all these different things. We have this array of task stacks, and the task stack as the guard page, which is a stood array, right? Isn't it address of guard page plus size? I'm trying to see if the address is greater than or equal to the address of begin. Yeah. Yeah. Just gonna quickly split array. Trying Turns an iterator to the beginning. Right, to the first element of the array. Turns an iterator to the end. To the element following the last element of array. Right, that's like the whole idea with this thing. End is sort of like one past the last element, so I'm thinking that this could be decent. There might even be we could even maybe use one of these algorithms like the stood like find if or something like this. End -1 plus size of task struct. Not quite getting that, but let's just yeah, anyway, we could just do some tests like I mean, this would be kind of interesting actually. Let's just see. I'm just gonna make another function. I'll test func just for the moment. So what yeah, interesting. I just want to like as adder in any guard page. So interesting. We want to pass in the buffers are exposed here, right? They're stored. Okay, so I should be able to do I really need some kind of like test assert something, but it's like what I'll just do right now is buffers.m tat stacks. Scheduler there we go. Scheduler buffers.m task stacks. Dot begin, for example. And this is complaining because I need to pass in the scheduler buffers. If yeah, this is going to be kind of weird. I want some kind of assertion macro, something like this. Sub Tugra, sub Shubham. I'm new here. Welcome. You're very welcome. We're just hanging out, doing some kernel programming. 28 people in the stream. It's a pretty good stream today. Yeah, I mean, ideally there's some. But like just to get really basic, you know, let's just let's just do another if. But actually, we don't need to have a test ID here. Actually, it's not even being used. Okay, is adder in any guard page, and so so here we're going to kind of flip the script and say test passed. You're here. Where to even begin with kernel programming? Shouldn't the default address and guard page bounds be cast to before comparing them? Adder is a void star. Yeah, you might be right. You might be right. I mean, yeah. It's totally possible you know more about these rules than I do. Yeah, maybe it's more idiomatic to compare uint pointer t's. I mean, we're not really doing math per se, we're just doing comparisons, but you are totally right. So let's just say so we're passing in the begin, which should very obviously be in the first guard page. If it's not in that, we're going to fail the test. Otherwise, we're going to do a test passed. Right. This is kind of interesting because actually this could be a unit test, frankly. It's sort of strange to do this in an integration test. This is actually, this is a great example of something that it should be unit testable, actually. The only tricky thing is the buffer's type. I don't think that's in kernel lib currently. Anyway. Pass, right? This dash v makes it looks like it failed, but it passed. And so now we can do some tests. Like for example, -1, right? So we're gonna take the begin, we'll sort of straddle the end. We'll do a +1 over here. So like, dude, I wonder what, yeah. Like it would be cool to have some macros or something around this. Are you using any framework for testing? Not for the integration test, which is why it looks so ugly, because I have zero framework. So it's like, if this is not in any guard page, fail the test. If this is in any guard page, fail the test. What else? Let's do the other end. So basically, end. We're gonna go with end -1, which is going to be if it's not in, to fail the test. And then if end is in there, we'll fail the test. And then if n, n +1 is in there, we'll fail the test. So yeah. And now that I think about it, there's no real reason to... I mean, there's so many things to improve about this, but there's no reason to panic per se. We could just log, but then it would be hard to actually see which test failed. And so that's sort of Mark be testing arrays. Yeah. Pass. Okay. Just to see this, let's just return false all the time. This should always, it should fail the test. What is going on? Why is it hanging for so long? So we injected a bug, which always returns false. Oh wait, it's because I have underscores here. So yeah, that's why. Fail. And so yeah, let's change, I don't know, let's change these to logs maybe. Although interestingly, it's going to hit test passed, which is going to confuse the scripts. So yeah, so maybe never mind. So now we can see that the test failed, and if we wanted to debug it, I guess, oh, we can look here. So it fails on line 24. Log would still fail the test hard. And the reason the idea was that like, it's possible to just sort of run a bunch of these. Like just because one test fails doesn't mean we can't keep running the other tests and see if they pass or not. But yeah. And so, right, so now we're seeing our very first test is failing because we injected this bug that says everything is in a guard page. And so this is like if, yeah. And this was testing if it's not in a guard page. All right, this is interesting. So I think what I'm learning from this is that, yeah, we're sort of going down this whole rabbit hole of, of work to implement a custom test framework. In this case, it's ironic because this is actually a case where we could totally unit test it. Let's actually see what that would look like. I think I will just quickly but I also want to get back to there's this really good comment about the Camiono. Shouldn't the default address and guard page not be cast to unit pointer t before comparing them? And I think that's a question I'd like to actually clear up. So the question is, should these things be casted or not? And I'm gonna say no, because the type of these, okay, the type of this is void star, the type of this is char star. Okay, so maybe the most technically correct thing is to never do comparisons or math on a void star. I think my understanding is that in practice this kind of works, but that's actually a good question. I'm going to ask a lot about it. Start with a char star. Is this legal, or would it be better to either one cast them both to char star or to cast them to uint pointer t? I thought since we're not doing math, it's not necessary to use uint pointer t. FBI freeze, you're comparing a void star with a char star. I need to fix this at some point. It keeps trying to use SIMD.json, which is not working. This is a good question, though. Yeah, you might be right. Let's see. Seems kind of slow for such a basic question. Yeah. Okay, so Camiono, this is what the AI said. Like technically it's legal to compare void star and char star with C++, but technically if you're trying to be super pedantically correct, uint pointer t is technically the correct choice, something like that. If when both pointers point into the same array or allocation, and that's not really the case here. Our adder is an arbitrary address. In practice, it's just an integer comparison, so we'll just document that over here. Yeah, no problem. It's a good question. I'm just here to learn, and there's always more to learn about these kinds of things, and so now we know. It's a very reasonable question because it's this type of topic is so error prone and it's so easy to have subtle bugs when you're comparing pointers and stuff like this. So, okay, so there's clearly a lot of work to do here. I mean, we're going in, so add a func to tell if a pointer is in any guard page, then use that func to only panic if in the PF handler if the adder was in a guard page. So the whole point so the whole point of doing this thing, I mean, there's many obvious flaws and all right, 20 seconds, be right back. The integration test for is adder in any guard page could be a unit test, lol. So that is a very particular point of irony. But that's not really the main point. The main point is focus on here. So the idea is just to, now we can use this thing. And so interesting. Yeah, sort of now, does the trap CP need to depend on the scheduler? That's a little bit yucky. Yeah, it's not really amazing. But for the moment, in the spirit of just hacking away to do this is all. This is only for, maybe move that to a separate header so this doesn't depend fully on scheduler.hpp. But whatever, I think it should still be fine as long as there's no circular dependency, which I don't think exists. So, and so now we can just be like auto defaulting address, right? And it's like if is kernel.m buffers.m buffers defaulting address. Wait, no, this is this is why I have an assert, so it's more like assert. What's the type? This is a UN64T, so oh, actually, yeah, this is always that thing where you can't cast a UN64T to you can't static cast a UN64T to a, so you need to reinterpret cast it, which is always kind of unpleasant. But now, wait a sec. Okay, so yeah, nah, it's worth just to exercise the integration test muscles, build them in the first place. I mean, it was kind of cool that we were, even though it's kind of the wrong tool for it, we were like technically able to do this. and write some tests for it. So it's an interesting use of the infrastructure, even though it's like super ugly and verbose. Yeah. Okay, so now here's the idea. I guess technically my kernel is still not handling page faults, but let's just think maybe a little bit. Okay, before I go into this whole assert thing, I'm actually just going to simplify things and just do a simpler version just so I can see it. Init guard page right. Yeah, this is the idea. So in the page fault handler, it's specifically checking, are we doing an access to a guard page? We're still doing the test 0 here. And so if I run the kernel, we should, yeah, we're hitting this panic. Good. Writing to guard page access. Good. So now the idea is, okay. So the goal is to not hard code test past all capitals into this code. So how do we want to handle this? So so somehow it's sort of like if in integration test mode, which doesn't exist, okay, I'm actually a little bit, like, under specific cases, we actually don't want to just panic. If we're specifically in this integration, if we're specifically running this integration test, we actually want it to succeed. In this case. So I am a little bit unsure how to, but in theory, I'm thinking something like this, where it's like, yeah, something like this, but it's interesting, but because the idea is to not have to grep for specific things here, but have the kernel sort of watch and then communicate some kind of test result. And it's not just for any integration test. It's for this only for this very specific integration test. If we are in this one specific test, then, and we actually land here, we want to pass the test. And that is sort of where it gets kind of tricky, because now we sort of want to set some kind of state or have it be kind of scoped around this one, for this like one particular operation. We want to enable the bool. Maybe I can just hack this real quick. As usual, I'm just gonna hack it like crazy. I'm gonna add a global bool. And this, yeah, I don't know, guard page test. Don't look at what I'm doing. This is super embarrassing. I'm adding a global bool to the kernel, which is bizarre, but for almost all the time it's going to be false. And what I will do though is like, I don't know, something like this. My scheduler. Unit. Yeah, so this is kind of strange, but that's sort of the idea. It's like under very specific circumstances, the kernel is sort of branching itself and sort of behaving like it's under test mode. And so let's just see this work. And so I should be able to I'm doing this task write to guard page thing. Again, we don't need this string. So yeah. So when I run this test, it's going to run here. It's going to run the kernel with this one task, which is going to do this right to the guard page, and it should panic with test passed. So let's just try that. So that passed. If we comment this out, I actually want to do something. I want to, okay. I sort of wanted to stream the output of the log. I don't know how hard or easy that is because I don't really know Bash and was sort of vibe coding this. Anyway, let's just wrap it up. So back here, so we're going to comment out this thing, which means that we're going to hit this normal panic, which is going to trigger the timeouts, unfortunately. And I think the timeout's kind of long. Timeout's 30 seconds. I don't really know how long it could be. I'm gonna change it to be shorter. I'm gonna change it to be like 8 seconds, maybe. Okay, so now what's gonna happen is I'm gonna run the unit test. This bool is not enabled, and so we're not gonna pass the test, and we're gonna hit the panic, which will hit the timeout and fail the test, probably. Yeah. Fail, timeout after 8 seconds, blah, 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 writing to our page, panic. So hit the panic, like the production panic. Yeah, hit the production, the panic that we would normally hit in production. So that shows that things are kind of working. This has been very interesting to experiment with. It could even be this run with flag on or something like this. Where we do it sort of like this. And you can have a lambda that just runs while with test flag on. I don't know. This is all kind of weird. It's kind of a cool idea, but this specifically is the part that's weird. I added a bool to the kernel itself. Which is super weird. Like it adds like test state to the production kernel. And it's also, it seems like this state needs to be kind of specific to a test. Like I was sort of wondering if we could just do some kind of Boolean that's just sort of like, are we in test mode? Are we like just a single flip, like, are we in test mode? And then if we're in test mode, a bunch of these checks will like convert to test passed. But I don't know if that's really safe because, what am I doing? Because you could imagine, let's say we just have some other random unit test that's testing a bunch of other random stuff. And it's in test mode. And it accidentally triggers a write to a guard page. That test should fail. Like, that's bad. But if we only have a single bool for all unit tests, and then we just flip it on, then this code, it's going to see that we're in test mode. And it's going to pass the test, even though it shouldn't, because we're not testing this particular test. And so it sort of seems like we need some kind of like fine-grained like flags almost. which is interesting and kind of weird. For the test flags, if we had a single test bool, then an unrelated test could accidentally trigger a guard page access under test, and that would print a test passed message when it should actually fail that test. So it seems like we need something different, some kind of like kernel or like integration test flags. Something like this. And and then there would be like the integration test flags over here or something like this. So I'm just going to jot down some things I learned from doing this. The flags need to be on the granularity of the tests. Otherwise, test failures might be marked as passing. Yeah. Dang, so anyway, so these that's been some experimentation around trying to get some integration tests going and what it would look like. But maybe just to finish it off, so here's an idea. We could use strings. That's a little bit odd. Let me see though. So the idea behind this integration test flags. So again, my header dependency management is going like out the window. But let's just say this, we're going to include let's just say we're going to do this. We're going to have the integration test flags here, and now trap.c now this is what it's going to look like. So for some kind of arbitrary integration test, it can register a test flag. And then this thing needs to have some kind of other argument. It's like, I don't know, we could do something kind of weird, like we can pass in a pointer to a bool. And this thing, or yeah, let's just pointer or a reference. Maybe it's a bit clearer. Wait, what am I doing? Right, so we pass in a pointer. We enable the flag, we call the function, then we disable the flag. That's sort of how this is conceptually works. And so an arbitrary integration test can register a flag with the flags. It can then use this function called run test with flag. Maybe run test with flag enabled? Or run test with flag? Or maybe, I don't know, whatever. Run with test flag, yeah. And it can do some stuff. And then inside of the relevant code, it can then check the flag. And pass a test under specific conditions. And so in practice, and ideally we don't want to hard code this kind of thing everywhere. So it's sort of like integration, like test pass if, maybe it's like some macro. And it's just something like this. Yeah. Which, and this macro, if it needs to be a macro, I'm not sure if it needs to be a macro, but it then just basically does this thing where it's like if we're in some spot and we see this thing is set, then pass the test, something along those lines. Yeah, so that's the idea. Oh, but maybe now I've broken the build. Because I think I've now triggered. Yeah, I've triggered a cycle in the includes, unfortunately. Right, because it's like a circular include, because kernel is now depending on integration tests, but integration tests were depending on the kernel already. So it should be like this. And so now I just have my flags. Because the kernel only really needs the flags. So I think, and now this thing needs the integration test flags, and this thing can go away. So now does that fix the build? That fixes the build. And now I can again go back to this whole thing. So I can try to do my write to guard page test. It passes. And just for the full kind of view of how this works, let's say I was actually working on the scheduler and I broke things. Let's say I actually refactored the scheduler and introduced a bug where I forgot to unmap the guard pages, which means that writes to the guard pages are now going to be fine. The goal is that this test should fail now, and let's just see if that happens. Check it out. Fail. Write to guard page failed. So I just ran the exact same test that I just ran, but I have the bug injected now, and now this test is failing, and it's saying that, okay, on line 32 of here, and I think we actually don't even need this because the idea is to have this big catch-all thing at the end here that fails all, it just fails everything if it gets here. And the idea is that every test function should, if it passes, it should communicate a test passed. And so I think that's working. I think that's actually working pretty well. So we can see that the test fails. This one actually timed out because it hit the landing pad. That is interesting. You can see that it hit the landing pad. I was wondering why it was taking so long. And the reason is because every task needs to exit with scheduler.task exit, which is kind of cumbersome for these tests. And so that was just a decision I made that all tasks need to explicitly end with a task exit, which is a bit annoying. So now if I run that again, we should see the test failure because I still have the bug injected. Idle task. Oh, it's still timed out. Oh, now it timed out because it hit the idle task. That is interesting. Okay. Easy to forget that this is just a kernel task. And the control flow is not quite so simple. Oops. So we call this function, at which point the kernel just like runs and hits the scheduler forever. And so this actually just, we never get to this. Actually, this just never returns, which is kind of interesting. Again, we could imagine some special situation where under test specifically, the scheduler actually does return. Usually the scheduler never returns, but we could make it such that it did return under test. But in the absence of doing that, that means every test needs to actually specifically end with a test passed. Otherwise, yeah. Otherwise you just like time out because the idle task just runs forever. So that's why. So now this should actually fail again. Wait, but it passes now. Wait, why did it? Oh wait, because that needs to be. The pass happens in the kernel code, and then if we don't see that, we immediately fail the test. Test failed. And then now if we fix the code, make it behave correctly, we pass the test. All right, I think, yeah, that's a solid progress checkpoint for today, I think. It's not the most beautiful test framework, but it kind of works. So in the progress bar, so we sort of got to this point. And framework tests can register test flags, which they can check at specific points to pass an integration test, question mark. Yeah, I think there's still a lot more to really try out here to see if this is a viable idea. But even if it doesn't really work out in the end, this was interesting to try, at least. So we can sort of start to wind things down. Camiono, well done. Thank you very much. Maybe I can just get a quick temperature test from anyone watching the stream right now. On a scale of 0 to 10, how well were you understanding what I am doing today? Like 10 being fully understand, 100% understanding, like totally with you. 1 being like, I don't get absolutely any of this. Put a message in the chat, like where you are on that spectrum. 1, I don't really get any of this. 10, I understand everything fully. 5 is like, I sort of get some high level concepts here, but it's a bit, it's maybe a bit vague. So, or a bit, yeah, not quite there with the understanding. Maybe a name for what it does for the bool, like force page fault pass. I see. So maybe like name the flag a little bit differently. Yeah. Just perhaps some nothing to say. Cliff bites. Camiono at the 10, at level 10. Okay, cool. Cool. Glad to hear that. Sometimes I'm just, yeah, sometimes I know it can be like just really hard just to sort of like understand what's going on, especially if you just jump into this kernel stream. So I'm just always curious to hear how people are receiving stuff. Terry Davis reincarnated. What's up, 00 Origa? How do you keep yourself going on this project? Have you ever thought of giving up? Question mark, exclamation point, exclamation point. I keep going because it's a lot of fun. It feels cool to watch this OS slowly grow and get bigger and better week after week. It's fun to engage with the community. I learn stuff every single week, so it's actually really fun. Have you ever thought of giving up? I mean, yeah, I do think of giving up. It's not always easy, especially to stream everything and to sort of, I feel pretty stupid a lot when I don't understand things very quickly. So I do think of giving up, but not very seriously because it's a lot of fun. And so far, yeah, I just always enjoy making some progress and learning new things every week. Appreciate that, Camiono. Thank you very much. Thank you very much. So that's cool, guys. I think that will be it for today. But yeah, that was the stream. Working on integration test framework, really having a way to boot the kernel and test some specific behaviors and have that be able to run in some kind of automated test suite so that I don't need to do manual testing and like commenting code in and out to test that my kernel is working. So I think I'll just end the stream again with a quick little message, sponsor message from myself. If you hadn't heard, I would love to talk to you about any challenges you have in the world of systems programming, because I want to learn how I can be more helpful to my audience. And I would just invite you to contact me if you're interested in talking about some of your challenges, whether they're technical challenges or career-wise or something else. Feel free to just get in touch with me. My contact is all here: Discord, Instagram, my email, mark@offlinemark.com. This information is all in the description of the stream too. So, yep, I think that's going to be it for today, guys. I really, really thank you for popping into the stream, and I hope you have a good one. Yeah, I'll be back at it next week. Follow the Discord, join the Discord if you want updates. Occasionally I do change the schedule, but usually it's every week, Sunday. All right. Well, hope you have a great week. I will catch you later.